Yeah, that can be a bummer.
Yeah, and she's like, it's okay. He just said I was right about everything. That's all that happened.
Smart guest.
Yeah. Yeah. All right. Looks like we're live. So, Rick, thanks for coming on. I really appreciate you taking the time to have a conversation with me. You recently released a video, the end of quantum reality. I wanted to talk a little bit about that. Could you tell us a little bit about the movie and about yourself before we get started?
Yeah, sure. The End of Quantum Reality is essentially a documentary film examining the life and work of Professor Wolfgang Smith. I had encountered this man sort of as a hovering spectral presence when I was doing my first film, The Principal. And he was this guy that everybody had heard of. Nobody knew where he was, if he was still alive, but he had some pretty ferocious credentials, for a guy who was clearly quite open to the ideas that we expressed in the principle. The guy was, accepted into Cornell at 14 years of age for masters in mathematics, physics, and philosophy. Got those degrees at 18, had his graduate degree in quantum mechanics by the time he was 20, and was teaching mathematics at MIT by the time he was 25. So this is a guy who had the platinum credentials, so to speak. And when I finished the principle, which was an examination of the challenges facing our present worldview in the very large, in cosmology, I wanted to do a follow-up that would examine the challenges in the very, very small, which are even more profound. And of course, Dr. Smith is the author of an absolutely stunning book called The Quantum Enigma. So, long story short, I decided to try to find out if he was still alive. I found out that he was. He had retired years ago. He was in seclusion. He did not want to talk to anyone. His books spoke for themselves. He couldn't care less about, any further. He was in his late 80s, and he figured, he was going to enjoy life with his lovely wife. But it turned out he had seen the principle. And so when I contacted his publisher in New York and identified myself as the producer of the principle, I got to speak to him. And that was the beginning of what has blossomed into a very dear friendship. And that's really the way we got this film made.
Yeah, awesome. The comments are saying if you could talk a little bit louder, they'd really appreciate it. You're still a little
I
quiet.
certainly will. How is this? Is this okay for everybody?
Yeah, that sounds good. That sounds good for me.
Okay, I'll remember. I'll remember to use my stage voice.
So the title of your movie is "The End of Quantum Reality." What do you mean by that? Like, what is? Do you mean like an end to the view that the reality is quantum, or an end to quantum mechanics as a field? What exactly do you mean by that?
The first and not the second. Um, the film is ultimately not about quantum mechanics because Wolfgang Smith absolutely is persuaded and has been his whole professional life that quantum mechanics is physics come into its own. He learned quantum mechanics. I mean, he was at Cornell when Feynman was at Cornell. So he learned it the old school way. I mean, the rigor back then was pretty profound. Uh, what they managed to persuade him to the core of his being is that quantum mechanics is the correct bottom physical theory. And because really, once you accept that, the only question is, what does it mean? The only question left is not, strictly speaking, a scientific question. It is a question of metaphysics, of ontology. And the reason we chose the title The End of Quantum Reality was to convey that the real subject of this film is reality. What do we mean when we say that word? I mean, what is it that we are actually signifying when we say reality? And to point out that 100 years in, Heisenberg turns out to have been right. He was the first genius of the founders to formulate quantum mechanics. He did so by means of a profound sort of approach, which is called, hardly anybody remembers this, but it used to be, very important, called the Heisenberg cut. And what Heisenberg said is that in order to do physics, you have to have a distinction somewhere along the line between the system that you are going to measure, which is beautifully described, by the way, by quantum mechanics, whether you prefer the Heisenberg formulation or whether you prefer the Schrödinger formulation or the Dirac formulation, it doesn't really matter. Until you measure that system, it is beautifully described by quantum mechanics. But Heisenberg said if you want to turn this into physics, then you have to put a cut, in German, a Schnitt, great word, a Schnitt, in between the system that you are going to measure and the measuring apparatus and the environment, which is just the rest of the world. And without this Schnitt, Heisenberg said, you cannot turn this into physics. So the Heisenberg cut, or the Schnitt, was the basis upon which Wolfgang Smith fastened on to this question. Because we really have a fundamental problem here. If reality is quantum, why is it that the world does not in any way, shape, or form look quantum to us? I am looking at you, you are not multi-locating, you are not in superposition, etc., etc., etc. And yet, how is it that this physics is so accurate that we can conduct this discussion over this computer today precisely because of quantum mechanics? So that paradox has been hanging around for 100 years. It is not strictly a scientific question, but it is a profound one.
So what did you mean when you said the end of quantum reality?
That we will never be able to construct a world picture that assumes that the world emerges from the bottom up. In other words, one of the two most powerful and successful assumptions of the scientific enlightenment project has failed, and that one is reductionism. The world will not be found to reduce down to these fundamental particles, which of course was the assumption that led to 400 years of science, 400 years of triumph.
Well,
But we've reached the end of that road. It's not going to work.
Well, what do you mean? Because when I understand reductionism doesn't mean we're going to necessarily reduce just to physical particles. It can reduce to any natural things. It doesn't necessarily mean it's going to reduce to particles. So why do you assume that reductionism has failed as a complete enterprise when I agree we're not going to reduce to just particles, but that doesn't mean we can't reduce to other things.
Okay. Whatever you reduce to, it doesn't matter what. You can reduce to many worlds. You can reduce to guardian angel pilot waves that push particles around, knowing the past, present, and future of the universe. It doesn't matter how you try to get beneath quantum mechanics. It doesn't matter, because you're still going to have a measuring problem. You are still going to face this fundamental paradox that you have a system that is beautifully described by your mathematics right up until you measure it. And when you measure it, something absolutely discontinuous and, from the point of view of reductionism, inexplicable happens. My photon is perfectly described by the Schrödinger equation until it hits the photographic emulsion, at which point the Schrödinger equation instantly collapses. And all of the probabilities which described that photon are collapsed down into one specific location on one specific photographic emulsion plate. And you're never going to get around that. There's nothing you can do. You can postulate many worlds, but that's not a scientific solution either. We have no evidence of that. You can't take me in, you can take me into the laboratory and show me photons impacting that emulsion plate.
But wait, why do we need evidence? Because the idea of reductionism doesn't mean that we can know what everything reduces to. It's just that everything does reduce. So it's possible that it reduces to a multiverse or whatever. The fact that we know it is irrelevant. So the measurement problem is epistemic. Can we know both the position and momentum of two particles?
I must say this is a point upon which we fundamentally disagree. The measurement problem is not epistemic. It is ontological. And this is fundamental. If we allow it to be epistemic, then there is nothing to stop us from sailing through the looking glass into, well, the moon isn't there until you look at it, or every time you blink your eyes, the universe is splitting off into as many copies as there were potential values for the observables of all of the trillions of quantum particles that you just blinked the branch into. Now, let me say right off the bat, it is perfectly possible to make a mathematical world in which those things occur mathematically. We can sail off and spend perhaps 300 years arguing about which multiverse we occupy and what other multiverses might be this, that, or the other thing. What we will never be able to do is conduct any scientific experiment whatsoever, any crucial, reproducible test of that hypothesis. Therefore, it is not a scientific solution.
Well,
What
actually,
we
that's
can,
we may actually be able to do tests that can verify the multiverse and those other theories in the future. Those have been hypothesized, but that's a different issue because in those models, the measurement problem is solved. Like there is a solution to the measurement problem, which means the
no,
measurement problem is
I disagree with you. The measurement problem is not solved. It is swept away under the carpet, but we still have to deal with this universe right here, which is the only one in which we can conduct scientific experiments. It doesn't matter if we want to build a if we want to build a semiconductor and we want to have a physics that actually works to produce that semiconductor. Believe me, the number of branches in the waveform that are instantiated on pointers in the other universes is not going to enter into our equations. And in fact, they can't. They can't enter into our equations. There's a deeper problem here, and this applies both to Bohmian mechanics and to the many worlds Everett interpretation and to the flash collapse models. All of them are going to hit the wall very soon. It's already starting to show up in the literature. There's a problem related to
what wall?
thermodynamics here,
What wall?
the wall of falsification by direct observation.
Well,
The
okay, but
problem
wait,
here,
stop, stop. So, because again, reductionism doesn't say that we need to know it. So, the multiverse could be true and we just don't know it. I mean, that's possible. And
well,
if
that
it's the case,
if it is a scientific theory, it must be at least in principle possible to falsify it.
it doesn't need to be a
If it is
scientific theory. So, again, reductionism isn't
okay,
a
so
scientific theory.
if you assume it is not a scientific theory, then all we are talking about are metaphysical preferences,
Right, that's what
and
reductionism is.
the discussion should be situated on metaphysical grounds. I'm not quite ready to surrender
Oh, no,
science
no,
on
no.
that.
So, again, remember, you said reductionism has failed. Reductionism is a
Yes, it has.
metaphysical position. Reductionism isn't a scientific hypothesis.
That's
Reductionism is a
exactly right. It
metaphysical
is a
position.
metaphysical assumption about reality.
Right,
So
right. So,
here's the
so when
thing.
you say reductionism has failed, I mean,
Yes, yeah, that's
it
fair.
may not have, because if the multiverse is true, then reductionism has succeeded.
But the multiverse cannot possibly be true, and here's why. There are many reasons, but here is one that I think is particularly compelling and is showing up in the literature more, and I think will heat up a lot over the next few years. It comes down to this. When you are doing quantum mechanics, you get an absolutely marvelous correlation to what we observe in the classical world because quantum mechanics has within itself certain mathematical aspects that prove to render quantum mechanics an excellent way to describe what we ultimately view in the real world. For example, we have something called the Boltzmann constant. Are you familiar with that?
Hmm.
Okay. So that tells us that the degrees of freedom necessary for a molecule to be made up of quantum stuff has to be approximately the degrees of freedom that are allowed in quantum mechanics, which is a very small degree of freedom compared to what would be necessary to instantiate an quintillion other universes every time we blink. The amount of information in those particles has to be of order 1, because if it's higher, we violate the Boltzmann constant. We would see much higher degrees of heat dissipation in these processes than are actually observed. Quantum mechanics matches the Boltzmann constant perfectly because the degrees of freedom in those particles are greatly constrained by quantum
As
mechanics.
far as I
They are
know,
not constrained by the magical guardian pilot wave of the Bohmians, and they are certainly not constrained by the somehow branching off function that gives us trillions upon trillions of pointers and trillions upon trillions of universes every time we blink our eyes.
well, I think we definitely disagree about that because I can show that the math for both the Bohmian pilot wave theory, the many worlds interpretation, the multiverse, the EBM, they all correspond to all of the data in quantum mechanics. They explain all of it. There's no
But
energy
they do
coefficient
not
from the Bohmian.
correspond to the thermodynamics that we observe
Yeah, they
in the
do.
classical world. That's a fact. Now I can send you some references if you would
What do you
like.
mean? What do you mean by thermodynamic facts we observe in
Okay,
the real world? Because as far as one sec. So as far as I know, all of the data in quantum mechanics is explained by all of these interpretations. Are you saying there's some other data that they not in
all of the
quantum
data
mechanics?
in quantum mechanics is perfectly, in other words, you get the same result whether you do twice as much math like the Bohmians have to do for their guardian angel pilot wave, or whether you simply assume that there is nothing but a wave function, nothing else exists, and what we see here is just our particular branch of the wave function. That will give you the same outcomes of your experiments. What it will not do is give you the ability to account for the Boltzmann constant in the real world, in the classical world that we observe. The reason is this: heat dissipation is directly related to the amount of information in a given system, precisely the degrees of freedom in that system. There is a specific mathematical relationship between the degrees of freedom and the amount of heat dissipation that will be observed in such a system. Quantum mechanics matches observations in this regard perfectly. Neither Bohmian mechanics nor many worlds does.
Wait. You just contradicted yourself.
Hold on, let me just finish. You have far too many degrees of freedom required in the quantum particles in those two systems to account for observations at the thermodynamic statistical mechanical level. They violate the Boltzmann constant.
Okay, so they don't. They absolutely don't. So quantum mechanics.
Absolutely do,
no,
sir.
we can prove they don't.
You're
So
entitled to your
wait,
opinion, but you're not
stop,
entitled
stop,
to your own fact.
Stop. So again,
would you like me to send
go back,
you the?
go back,
would you like
go
me to
back,
send you the paper?
Go back. So again, quantum mechanics is what explains all of the data. The many worlds interpretation, the pilot wave theory, those are interpretations of quantum mechanics. They don't deviate from quantum mechanics at all.
But
They're
they
just
involve
interpretations,
thermodynamic consequences,
which are exactly
they
consistent
are
with quantum
not,
mechanics.
sir. You are now. This is something upon which you are wrong.
No, I
and
can prove I'm right here because I have. I'm sorry.
I would be happy to provide you with the actual papers that have addressed this in the literature.
I'm going to mute you.
Why
I'm going to mute
don't we
you.
do that?
You've got to stop for a
Why
second.
don't we start with the paper?
Because I can provide you the papers from Sean Carroll showing you're wrong, where he says that no, that doesn't.
There are no papers from Sean Carroll.
There are.
Sean Carroll has never even addressed this question.
Every observation in everything of our world is explained by every single one of the models. There's not a single observation one doesn't explain.
You can wave your hands all day long. That's simply false.
Then they wouldn't be accepted.
In fact, in the peer-reviewed literature, proof that the degrees of freedom required for Bohmian mechanics and many worlds to actually result in the world we sit in right here require many, many, many greater degrees of freedom, first of all, than quantum mechanics allows, and second of all, than the Boltzmann constant allows. This is a fact. Would you like me to send you the paper?
Yeah, feel free. I'm going to say it's wrong, and I'm going to prove it's wrong pretty simply because that's every single one of the interpretations explains all the data. That's kind of the point.
That's false. It does not explain
it's true.
The thermodynamic consequences of the degrees of freedom of action.
You can say that. You can have that opinion if you want, but I'm going to go with the actual physicists.
It's not an opinion. It's a mathematical derivation from the Boltzmann constant and the degrees of freedom.
You can believe that if you
necessary
want,
in
but I'm
both
going to
of
go with the
those theories.
physicists. You can believe that if
The
you want.
physicists who wrote the paper, my friend. You see, this is the problem. You're simply not up on this. You should get up on this because it's happening right now, and it's pretty interesting. There have been very few attempts lately to really test whether all of these formulations and interpretations of quantum mechanics could ever be subject to an experimental falsification. Here is one avenue upon which they are in present time being subjected to that. Now, you aren't aware of them. That doesn't surprise me. They are out there.
Nope.
I'm going to send you one of them as soon as we're off here.
I'm looking at the poll right now of physicists.
To your reader, to your listeners.
I'm looking at the poll right now of physicists, and the amount who accept the many worlds interpretation far outweighs pretty much all the other models. The Copenhagen is
thank God
first.
science doesn't come down to a popular vote. It comes down to what we can observe, test, measure, and experiment upon. Now, the Boltzmann constant is something that is very well established.
So again, you've got to stop and let me finish my point here. So again,
okay.
The majority of physicists say you're wrong. I'm going to go with them.
Good, fine. But don't confuse that with science.
No, that is science. That is science.
With popular science opinion polls, it has nothing to do with science. For example,
the way science works is people interpret the data and it builds a consensus in the field. The reason people talk about the consensus,
Tom, the way science
this is a direct quote from the National Academy of Science.
Mind. Every single scientific discovery in the history of the world takes this exact form. Something that everyone knows is true is challenged by some observation. One mind, one physicist against every single other one in the world comes up with a theory that can explain this observation and still account for what we thought we knew before.
Right.
Every single scientific discovery takes the form of one guy being right and everybody else in the world being wrong. Yep. And the way we know that one guy was right is by experiment.
Yes, which then convinces the consensus.
Well, hopefully. I mean, it took a hell of a long time for some experiments to convince the consensus. But the point is, if in fact it can be shown, and it has been shown, that the degrees of freedom required for the particles and fields of Bohmian mechanics and many worlds, Everett's interpretation of quantum mechanics, if it can be shown that the degrees of freedom required exceed the degrees of freedom that are consistent with the Boltzmann constant, then we have found an experimental test to distinguish between quantum mechanics and these attempted improvements.
Yeah, I agree with you, but unless you can present that data to the experts and convince the experts, I'm going to say you're probably wrong. So
well, the data are out there being presented by the experts right now. I mean, this is a live issue now.
Sure.
So I would encourage you to just look into it.
If you convince the majority of the physicists, I will agree with you.
The majority has nothing to do with it, Tom.
No. The majority has to do with how I verify.
The question is, does the experiment show it?
No. Here's the thing. In order to understand the experiment, you have to understand the field. I am not a professional physicist. For me to believe anything you're saying, you're going to have to convince them. If you can convince the majority of physicists that what you're saying is true, then yes, I'm happy to grant that. But from right now, when I look at the majority of physicists, they say you're making stuff up.
No, that's not. They're not saying anything of the kind, John.
They are.
That's what you're saying. I'm not making anything up. For peer-reviewed publication on this question by specialists, the very specialists that you say you are going to listen to, but you won't listen to them.
I'm listening to them right now. Again, the polls show you have failed. That interpretation has failed.
But the polls have nothing to do with it, Tom. Who cares what the polls say?
No.
Science has always consisted in one mind overturning what
I don't think you understand how science works.
I don't think you
understand how science works.
Science is not a popularity.
No. Go back. Remember how you said one guy starts with an idea, he makes a prediction. The prediction is then presented to the consensus and convinces the consensus. So if you're right, if you're right, and there is a test that shows that one of the quantum mechanics interpretations is better than the others, then that's going to convince the consensus. And the fact that it hasn't means you're probably wrong.
Necessarily follows. I don't know that. Look, let me just ask you one question. let's assume for the sake of argument, strictly for the sake of argument, that there exists a real demonstrable problem with the degrees of freedom in these reformulations of quantum mechanics. The two big ones being Bohm and Everett. Let's just say for the sake of argument that there was an experiment, that there was a reproducible observation that would distinguish between standard quantum mechanics and Bohm and Everett on this question. At what point has science spoken, Tom? Has science spoken when that experiment is verified and reproduced and presented in the lab? Or is the science when 51 or 51.9 or 62 or 74% of the respondents to a popular science magazine poll say that it has been established? Obviously, it is when the experiment.
No, that's wrong.
Is
It's when
done.
it's when the physicists who actually look at the data have a consensus on the topic.
Fantastic. We have found a bedrock point upon which we disagree.
Well, this isn't, again, you don't get an opinion on this. This is like literally all scientists agree on
I'm
this.
sorry, sir. That's
No. You can just look at the National Academy of Sciences who specifically says that.
That is your opinion.
Nope. I'm quoting the National Academy of Sciences. So again, the way science progresses.
Tom, listen, the statement that consensus determines science is, first of all, ridiculously false. And second of all, is an opinion.
No,
it is an opinion.
No.
It is neither a fact nor is it a truth.
No, anyway, it is. It literally is.
We certainly disagree on this point, so we might as well move on.
That's fine, but I'm going to just read as the National Academy of Science says, for science to progress, the experts in the field have to be convinced by it. If you convince none of them, you get nowhere. That's the reason science progresses is by convincing the experts.
Well, Tom, I'm here today, okay, to tell you that there is a problem with both Bohm and with Everett. It's really new. I mean, it hasn't been circulating around that long, but it's in a number of papers now. It's being discussed on some of the leading blogs in the scientific world. You can go to Lubos Motl's blog, and he has done an extensive, very good treatment of this. And there are peer-reviewed papers that you can also access. I'm here to tell you there's a real problem here. And what am I doing? I'm persuading you. Okay?
Well, no, you're not. That's the thing.
That's fine.
I agree.
I'm doing my part to do what the National Academy of Sciences is telling you we should do. We should attempt to persuade based on evidence, and that's what I'm doing. Now, you can go ahead and say, I'm going to tune out of this discussion until 52.7% of the National Academy of Science agrees with you. That's fine. But please, don't confuse that with science. It is not established by 52.7% of the National Academy of Sciences. God knows.
So everything you said is exactly what every pseudoscience says ever. It's like, oh, we have evidence. Like the reason something becomes science is you have to use
I've given you access to a peer-reviewed study, and
which also scientists, which is also what pseudosciences say. They cherry pick studies to try and support their conclusion.
Well, okay, so you're just going to assume in advance that any possible evidence that I present to you today is by definition pseudoscience.
No.
Tom, all due respect.
Again, what I'm saying is,
if you consider that to be compelling, then God bless you.
What I'm saying is that if you have evidence, you need to convince the physicist. Presenting to me means nothing.
If you haven't convinced the physicist, presented the evidence, Tom.
If you convince the
physicist, do you think they care about me?
No,
they don't give a hoot about me.
If you convince the majority of physicists and the consensus, then I will believe that what you're saying is true. If that does not happen,
then we'll just have to revisit this question when that occurs.
Yes, and I'm fine with that.
Those who are of a more inquisitive bent might want to look at Lubos Motl's blog, which will give them access to all of the peer-reviewed papers on this. The title of his blog on the reference frame is Basic Lethal Flaws in Revisionist Interpretations of Quantum Mechanics. It's a great read, and I would encourage those who are not prepared to just sit around and wait for 51% of the vote to come in, who are actually interested in looking at this, which is a very interesting development, to go ahead and start with that blog. It'll take you to many interesting places. So anyway, what else would you like to talk about, Tom?
Well, yeah. I mean, I totally agree. I think it's fine to look at it, but I'm going to, since I'm not an expert, and I recognize anyone who's not an expert is just going to leave it to the experts to actually decide. And so,
Right, that's fine. So I won't bother you again with anything that's cutting edge that would challenge the opinions of whatever it's 56 or 52 or whatever that magic number is.
yeah, okay. So there is no evidence against the many worlds or Bohm at this point. So right,
That's
those
false.
they can. Well, no,
That's
since
false.
you
There
have.
is evidence against it, and you can see it in peer-reviewed publications. I've already given you the citation to
Oh, no. Remember, you
Modal,
said you weren't going to bother me with this because you can't
and
convince
the
the physicists.
evidence is available for anyone watching here who would like to investigate that evidence. Lubos Modal's blog, the reference frame, the title of the paper is Basic Lethal Flaws in Revisionist Interpretations of Quantum Mechanics.
Sure, if you send me a
It's a
link, I'll
great
put a
read.
link in the description. But again, you said you weren't going to bother me with this because this doesn't convince the physicists. The physicists say this is wrong, as far as I can tell.
That is the physicist.
Some.
Lubos Modal is one of the leading theoretical physicists in the world.
Hugh
my
Ross is a physicist, but it doesn't matter what he says. What matters is what the consensus accepts. So, unless you can convince the consensus, it's not
friend.
evidence against the
Again,
position.
that is nonsense. But
That's how science
but
works.
those who are prepared to simply sit back and wait until
already
Scientific
said that.
American tells them what they are to
You
think
already
about
said
a
that.
given thing, you don't need to bother yourself with this. This won't be on your radar screen for another several years. Those of your audience who are interested in seeing what is really happening at the edge, at the cutting edge of this question, well, I've given you the reference, and you guys can.
So in a few years, you might have evidence. Right now, you have cherry-picked
No,
papers.
that's a logical fallacy. The evidence exists now. It's the consensus that doesn't exist. So you're again conflating those two things.
No. So the experts in the
which
field.
basically, the reason that you're wrong is that you think science consists in 51% of the vote. Thank God, it never has. And it never will.
So you don't
When
understand
a
science. That's
physicist
fine.
is able to
but
show in his laboratory that a given thing is reproducible, he wins.
No.
Even if he's the only guy in the world who believes it.
No, that's
Oh, yeah.
not how science works.
But
Science
that is
requires
exactly how science works.
You
But
don't understand
anyway,
science.
This is
an important point because you don't understand science. Science is done by
No, you don't understand
reproducibility.
science.
One
think
person
science-
verifying it.
you think
I'm going to mute
science
you
is
if you don't stop.
consensus.
I'm going to mute you if you don't stop interrupting me. So one person
You can
reproducing
mute
it in
me
a lab.
anytime you like, Tom.
One
I mean, we've
person
had a great
reproducing
discussion
something.
here,
One person
and
reproducing something
we
in a
can
lab
end at any
is
time.
not evidence. For it to be evidence, you need other experts in the field to be able to reproduce it
That is
with
nonsense.
the same interpretation.
What you need is an experiment or a
No.
demonstration that shows you are correct.
No,
That's what you need.
No,
It doesn't matter if you are the only person in the world
no,
who
because
is able to show, for example, that there are moons orbiting Jupiter. There was one and exactly one person in the world who could show that there were moons orbiting Jupiter. And you know what? Everybody else in the world said he was wrong. And it took the better part of 150 years to move the consensus over to the right side of that question. But the question was settled the minute he looked through his telescope. As a matter of science, the matter had been fully established that very day.
Well, I'm sorry you don't understand anything about science. So, because everyone, like the people thought that you could had a tachyons that travel faster than light. It was done in one experiment. One guy did it in a lab and it was repeatable. Oh, and then he was shown wrong.
Except it wasn't repeatable, Tom. If it was repeatable, it would be physics.
What's repeatable mean? Repeatable means other people have to do it.
If it had been repeatable, we would have had the breakthrough. We would have had it right then and right there. Not when the 17,000th subscriber to Scientific American decided to add his name to a petition, for God's sake, Tom.
Again, so I'm not arguing for petitions. I'm arguing for what do the physicists actually believe. This is a poll of physicists. So the physicists need to repeat it.
Who cares?
The physicists.
Who cares what a poll
What do you think
says?
Repeatable means?
It means nothing in the face of one reproducible experiment that overturns what they all believe. Every one of their votes is worth 0.
Right. So until you can actually produce that,
worth 100%.
So until you can produce that can be repeated,
and politics.
So until you can produce that experiment, which can be repeated by the experts and they can confirm it and it
Yeah,
convinces
well, that
them,
process is
you're making
underway
stuff
as
up.
we speak. That process is
Which is
underway as we
great,
speak.
which is great. And once it
there
does
are
that,
those,
then
of
it's
course,
evidence.
like you, who would rather just sit back and wait for it to be told by whatever that magic number is, 61.
Again, repeatable. Repeatable.
Exactly.
So
Exactly.
if
And
I can't
that
repeat it,
process depends, by the way, that process depends, by the way, upon an experimental or observational basis for overturning what 62%
yes,
of the scientists in the poll said was true. That's how
yes,
science progresses.
right.
Science
They need to repeat
progresses
it.
precisely because somebody says, wait a minute, I think I found something here that doesn't match that 61% of the vote on Scientific American or that 67% of the vote on the National Academy of Sciences. Here, let me write this up and submit it to a journal, right? Let's see if I can get this thing published. Ooh, okay, I did. So now it's out there. Now you have scientists, not like you, Tom, not the ones who are just sitting around waiting for the consensus to change, real scientists who are actually going to test and attempt to reproduce, kick the tires, see if there's a mistake somewhere. This is real science. And I can tell you that's exactly what is happening with regard to the Boltzmann, or more broadly, the thermodynamic issues related to the many worlds and the Bohmian mechanic revisions of quantum.
Right. So until they actually repeat it, it's just some guy's paper with no repeatability. It's just a hypothesis.
No,
Yep.
it's a peer-reviewed, published.
Hasn't been repeated. It needs to be repeated. Remember, that's the point. Repeatability.
It's being repeated as we speak.
So it hasn't been repeated yet. So it's not evidence.
I've given you two references,
which doesn't help you.
You can go to Lubos Model.
Can I repeat the experiment? No.
And he will give you links to.
I don't want his links. I want to repeat the experiment.
Peer-reviewed
Peer-reviewed does not mean repeated.
That are presently circulating in the scientific community.
That's great.
That raise a profoundly important.
So I've already debunked this, and you haven't addressed my point.
Okay, no, this is really a waste of time. Look,
no. I want you to address my point. You haven't addressed my point.
It is experiment. I have addressed your point.
No, you haven't.
Many.
You haven't addressed it at all. So again, listen to my point and
I
address
would suggest that either we can grind this.
I want you to address my point. So can I? I'll say my point. I'll say my point.
I've addressed your point repeatedly.
You haven't.
Let me address it again. Okay.
You have to know what my point is to address it.
You say that science consists in a consensus of the specialists.
No, it's not my point.
Exactly
so
what
you
just
wrong.
said.
So let me
now
say my
you're
point.
denying what you said.
So let me say my point again, and then you can address it. So, in order for something to be science, it has to be repeatable. You agree with that? Mm-hmm. Okay.
That's what I said.
Yes. So for it to be evidence, it has to be repeated.
It has to be a crucial repeatable.
So if it hasn't been repeated, we don't know if it's repeatable. It's just asserted.
It has been. There are more.
Wait. I'm not done
one.
yet. I'm not done. So for it to be repeated, you have to have people who can repeat it, right?
Mm-hmm. Absolutely.
Now, I can't. I don't have a big lab to be able to do this. So I'm going to have to wait for the physicists to repeat it. And once they do, if it works, then that's
Jump right on in. The water's fine, Tim. There are studies being done on this as we speak.
So again, not done. You haven't let me finish my point yet.
If you're not interested,
haven't let me finish my point yet.
Let's move on to something you are interested
in. You need to stop
audience
so I can finish my point. You still have not addressed my point.
I've told them how they can find.
Right, and I'm happy to put a link in the description. So that again, so listen to my point. So for something to be evidence, it has to be repeated. For it to be repeated, you have to need someone to repeat it. And that's the physicist.
No. The evidence consists in the first experiment. The verification and validation of the evidence consists in the repeats of the experiments. Let me give you an example.
You still haven't addressed my point. You haven't even got to my point.
Tom. He didn't have another telescope on the other side of the world to verify his findings. He had the only one, Tom.
Now, and everything he said could have been a delusion.
Let me make my point here.
No, you haven't let me make my point yet. You haven't even addressed my point.
You make your point.
So
let
again,
me know when you've made your point.
Wow. Okay. Can you hear me at least?
Have you made your point?
No. Are you going to listen now?
Okay. Well, let me know when you've made it, because I've heard you make it 7 times.
No, you haven't. You haven't let me finish once.
7 times, and you still want to
are you gonna let me?
grind
Are you
on
gonna let me?
this.
Are you gonna let me make it now? Are you gonna like listen?
I've let you make it repeatedly.
You
Go ahead and
haven't
make
let
it
me
again.
finish once. So no, you haven't.
Of course I have. Of course I have. And of course,
So
you
are
haven't
you
let
going to let me make it
mine
now?
either.
Are you going to let me make it now?
I am happy that you make it. Let me know when you've made it.